All right, so we've actually gone through a couple different resistance formulas for how to find the equivalent resistance within a circuit. But there actually is one formula that you could use to specifically find the resistance of a wire. And this formula is a very stripped down version of a much more complicated formula that you might find to find the resistance of any object. But for this particular problem, we'll just be fine, or this particular equation, it's just to find the resistance of a wire. And by wire, we mean something that has a uniform shape all the way down, and it has two dimensions that we really care about. The two dimensions that we care about is we care about the length of the wire, and we care about what's called the cross-sectional area. What that means is if you cut the wire and you looked at it on the face and you measured the area of the face, that would be the cross-sectional area. We're not talking about like if it was some kind of tube-shaped thing, the surface area of it. We're talking about cutting it in half and finding the cross-sectional area of what the piece that would be facing you when you looked at the cut end. So based on that, the resistance of a wire is going to be equal to, it increases as length increases, it decreases as the cross-sectional area decreases or increases, and then there's one other variable we need to talk about briefly, which is the resistivity. Resistivity just has to do with the material in question. Some materials are better conductors or better resistors, and so they have different resistivity values. Something like copper, gold, or silver would have a very small resistivity value, so they would have very small resistances. But if I use something like rubber or glass or ceramics, I would have a very large resistance, and it would be a very large resistor. So I have drawn here a couple different resistors. We'll call this resistor A, B, and C. And you're quite likely to be asked questions that say something about like ranking or comparing these different wires that look like this. What we should recognize right off the bat is that this one here is very wide. Because it's very wide, we can think of it as being similar to a lot of resistors in parallel, because each channel of material that different electrons could go down is basically a new path that it could take. And as we add more paths, as hopefully you've already recognized, parallel circuits have lower resistance. So this wide resistor behaves kind of like a parallel circuit and would have a very low resistance. On the other hand, a longer resistor is functionally similar to adding more resistors end to end. If the first resistor had a resistance of R, adding another one on the other end, we already know how to do that. You add them together, and now it would be 2R. So the resistance increases with length, decreases with width, basically following the same ideas that we've already learned from parallel and series circuits. So if I was ranking these resistances, the resistance of B would be greater than the resistance through A, which would be greater than the resistance through C, because resistor C would have a very low resistance because it's so wide. So that's basically the resistance formula. They will often ask you guys questions about experimental design with this. And anything that you were asked to do, you just have to think about how you would graph or what you would graph versus resistance. If we're trying to figure out how length and resistance are related to each other, because resistance and length have that linear relationship, we could just graph R versus L, and we would have a line that if we found the slope of it would be proportional to or equal to the resistivity over the cross-sectional area. If we were to graph the something involving the area, we would actually have to do 1 over area, and the slope of that would be the resistivity times the length. So that's basically what we're doing with the resistance formula. You should not ever use this with anything involving a circuit. You would only use this if they're asking a specific focused question about a wire of different thicknesses and things like that. So thank you very much for watching, and I hope this helped.